so what we're going to do here is do problem number 3 out of our practice problems. And here we have a situation where we roll a 6-sided die, and it's a fair die. And here are the two events. One event is that when you roll the die, you get a 1, 2, or a 3. That's E. F is the event that you get a 3 or a 4. And G is the event that you get a 5. So let's talk about the sample space. The sample space is just all the possible things that could happen. You can get a 1, 2, 3, 4, 5, or 6. And then let's draw a Venn diagram so we can see what's going on. I am going to start by drawing a rectangle for S, and that's pretty much what we always do. The whole space gets S, and we draw a rectangle. And then these events, which are sets of possible outcomes, we use circles for. Now E and F both contain the element 3. So what I'm going to do when I draw F is I'm going to create an overlap there, and that's the intersection. So they both have 3. E has 1 and 2 also, and then F has 3 and 4. So that's how we can show E, the set E and the set F. We have to show them so that they have an overlap. And then G does not have an overlap, so for that reason I'm going to put it out there, like I'm showing here. And then S has 1, 2, 3, 4, 5, 6, and 6 maybe I'll put over here. So we still need to have 6, but it's not lying in any of those sets. To find the probability of E, what we do is we count the number of ways that E can happen. So how can we get E? So what's going on is we're rolling a die, and the event E happens if the die rolls either a 1 or a 2 or a 3. So that's three different ways that can happen. But in total, there's 6 possible things that could happen. You can get 1, 2, 3, 4, 5, or 6. And so there's a 3 out of 6 possibility or chance that you're going to get E. That simplifies to 1/2, which is 50%. The probability of F is the number of ways that F can happen, and that's 2 different ways, because you can either get a 3 or 4 divided by the total number of things that could happen. You could have 6 different things happen. So that's 2 6, which reduces to 1/3, and you can use a calculator to see that that's around 33.3%. Maybe we just leave it as 33%. I just arbitrarily made it 33.3. And for G, we look at the number of ways G can happen, which is just one way. You can just get a 5. It's only one thing out of 6 in total. And that turns out to be around 16% or 16.7%. Now, we move on to intersection. So probability E and F. That means that you roll the die and you get an outcome that's in E and at the same time as F. And that is intersection. And corresponds to intersection. And with and, you have that upside down looking A, or no, it's just not up. You have that looks sort of like an A. That's how you can remember that intersection, and that symbol is and. So we look at the number of ways we can have that intersection, and there's just one way, because you can have 3, and that out of 6 in total. Again, that's around 16.7%. Now, E and G is just, well, what are you going to get for that? I mean, E and G don't have anything in common. E and G don't have have no elements in common, and so that's the empty set. And you can use a counting rule with the empty set. That's just the number of ways you can get the empty set divided by S, and that's 0/6. Now you don't have to write all that out, because it's the empty set always has probability 0. Okay, so now let's go on to E or F. That's the probability of E union F. And I'm just going to, since I can't get both of those on my screen, I'm going to rewrite this picture. So here's E, here's F. I have 1, 2, 3, and 4. Or corresponds to union. And now what I'm going to use is the sum rule. I'm going to find out the probability of E, and I'm going to add it to the probability of F. Now, what you do when you find the probability of E is you count how many are in E. There's 3 in E divided by 6 total. And then there's 2 in F when I find the probability of F divided by 6. But what I've done is I've counted this intersection twice. So what I need to do is I need to subtract that intersection. And there's only one way the intersection happens, so I subtract 1/6. I'm using the unreduced form, so that makes 3 plus 2 minus 1 over 6. Why do I use the unreduced form? So that I can have a common denominator. So that's 4/6, which is 2/3, which is around 66.7%. Let's actually just, make the rest of this. Let's make G a little smaller now. It's the same picture as above. Okay, the probability of E or G is the probability of E union G. Well, that's the probability of E plus the probability of G. But see, in this case, E and G are disjoint. So you can subtract the intersection, but the intersection is the empty set. So there's nothing to subtract. So these are disjoint. So we don't need to subtract away anything. So probability E, we did before, is 3 out of 6. Probability G is 1 out of 6. So we get 4 out of 6, which is 2/3. Okay, so that's all.